My apologies, I got caught up right down here at the end. Anyway, what I was saying is that that we have an imaginary solution, and sometimes we do. We have imaginary solutions. If we're asked to solve the quadratic equation, we want to go ahead and solve it, whether that means we're getting real or imaginary solutions. And I think I had said plus minus. I had a distraction, and I didn't want to have to go back and redo the video, so my apologies. Anyway, solving this equation right here with no linear term produces two imaginary solutions. They're not real solutions. Had the directions said find real solutions, then I wouldn't count this as part of my answer because those aren't real solutions, they're imaginary. All right, 7. All right. We might be tempted to FOIL this, and it probably would work if we FOILed this and then use the strategy of solving by factoring from what we just did on the previous page. But notice that we do have a square. We would have a linear term, and I know it's a little weird because there's all those weird things in math, but notice that we have a quantity squared equal to a number. Well, we've been working with just x squared equals a number, or x squared equals a number. Same thing here. Well, we can think of the x plus 5 as just our x if we want to. We can go ahead and straight up bring in the square root and put the square root on both sides of the equation. So the square root undoes this quantity, this square here. So I would bring out x plus 5, but remember we're going to put absolute value around all of x plus 5, not just the x, but whatever was underneath the quantity. And then we have equals square root of 11 does not simplify. There's not a perfect square that divides out of 11. Okay, what am I ready to do? I'm ready to remove the absolute value, which means put the plus minus, put the plus minus in front. Okay. Are we finished? Not quite yet. I need to isolate x, so let me subtract the 5. Well, where do I put the minus 5? Can I combine it with the square root? No. Should I put the minus 5 behind the square root? Should I put the minus 5 in front of, up front in front of the plus minus? Well, it's kind of common practice to do that. So we're going to take that negative 5 and we're going to put it up front. Negative 5 and then the plus minus square root of 11. I'm going to come up here. I'm going to write these two solutions separately. X equals, I'm going to do negative 5 minus square root of 11. That would be the smaller number. And I'm going to do x equals negative 5 plus the square root of 11. These answers are great. They're irrational numbers. You could change them to decimals, but why bother unless we're requested to change them to decimals? So I would just say that these are my two solutions. So kind of pulling back before we go to the last strategy of solving a quadratic equation by quadratic formula. Okay, in this method right here, we saw that we had two real solutions. We had two irrational solutions. These are also irrational solutions, and we had two imaginary solutions to our problem. So it was kind of cool that we had a lot of different things going on here. All right, the final objective is to solve quadratic equations by using the quadratic formula. Some students really like the quadratic formula. You can solve any quadratic equation, no matter the form, any quadratic equation by using the quadratic formula. The quadratic formula is a one-stop shop. Okay, unless you're requested to use a certain strategy, like the square root or the factoring strategy, if you see a quadratic equation, you might go, you know what, I'm going to memorize this quadratic formula and I'm going to use it for solving every quadratic equation. So just kind of watch the directions on any assigned homeworks or tests. If it asks you to specifically solve a quadratic equation using a strategy, well then you have to follow that particular requested method. All right, so for a quadratic equation to be solved by the quadratic formula, which is kind of ugly right here, I would encourage you to memorize that. I'll get back with you on a future test if that's something that's going to be given, or if you can write that down. I have to look at the software when I create a test. I'm hoping that I can actually just give you that formula in the test itself, but we'll talk later. All right, the solutions of any quadratic equation in the general form, okay, can be found. Any quadratic equation, even these up above here, could have been solved using this formula. Okay, so we find the x values or the solutions by creating a fraction, and in the numerator we have the opposite of whatever b is, plus or minus the square root of our b value squared minus the product 4 times a times c. This is sometimes, this is what we call the discriminant. More about that later. All divided by 2 times a. So in order for us to use the quadratic formula, we've got to put the quadratic equation in general form, which means if it's solved for 0, we're good to go. So both these examples 9 and 10 are in general form. Okay. I would encourage you to go ahead and write out what the values of a, b, and c are. Okay. And when I look at this problem right here, I just want to connect to what we did on the front page. That extra example that I gave you, if you look back at that, this is exactly the same quadratic equation. We just happen to solve it by factoring. And so we're going to solve it with a different strategy, the quadratic formula, and our answer should be the same. So we'll be able to check. So structure is kind of important here. So let's write down x equals, get a fraction bar. I need the opposite of whatever b is. Well, b is positive 8, so I'm going to make negative 8 the beginning of my numerator, plus or minus. I'm going to go ahead and build the square root. So b squared. So I'm going to go ahead and write down 8 squared. I'd put 8 in parentheses, 8 squared. That becomes important, especially if b becomes, if b is a negative number. Sometimes students forget the parentheses and they end up squaring negative 8 without using parentheses, and they get negative 64. But negative 8 squared is positive 64. Minus 4 times a times c. Make sure you extend that fraction bar. Structure matters. Extend the fraction bar too. The square root bar and the fraction bar. All divided by 2 times 1 here. All right, slowly, step by step, let's clean this up. I would target what's underneath the radical first. So I'm going to bring down negative 8, and I know I have 2 here. Then I'm going to have plus minus. I encourage you to go straight to your calculator and just input this the way you see it, except for don't use parentheses, I'd use multiplication. So I would make sure and use parentheses, especially if you have a negative number here. If you don't, you can just do 8 squared. And then minus, and I would do 4 times 1 times 12. That gives 16. Okay, at this point, really all we have to do is simplify, clean this up. If you remember our answers from the previous worksheet, they were integers, so I knew I didn't have any radicals. So I still have negative 8, and I've got 2 here, and I still have the plus minus. Square root of 16 makes 4. A lot of things you can do here to clean this up, but I think what I'll do is I'll go ahead and separate this into 2 answers. Negative 8 minus 4 goes over the 2, and then negative 8 plus 4 goes over the 2. I just like to do the minus first because it's the smaller number, and because I'm running out of room, I'm going to work across. So negative 8 minus 4 is negative 12 divided by 2, and that's going to give us a solution of negative 6. Negative 8 plus 4 is negative 4 divided by 2, and that's going to give us negative 2. I think those were the answers we got, I hope. Yep, I think they were. The only reason I don't like to work across is because x's label is far apart from negative 6, and x, you know, that label is far apart from negative 2. So I might just kind of clean this up and put x equals negative 6 and x equals negative 2. All right, more quadratic formula. All right, we're in general form. I'm going to use the quadratic formula. Let me go ahead and list A, B, and C. Now, unfortunately, on this one, you could not factor this. This would be what we would call prime. It doesn't factor, but I can still solve it by using the quadratic formula. So if factoring doesn't work, because you prefer factoring, then you're going to have to go to quadratic formula. So we're probably going to get some really crazy numbers. That's kind of what that's suggesting. So looking at the formula, opposite of b. B squared, well, b is positive, so I really don't need parentheses, but if it's negative, I'd put them there. Minus 4 times a times c. I use parentheses in written work, but when I go to the calculator, instead I use multiplication. And then 2 times 1. I'll do the easy parts first. 2 down here, -5 up here, and then let's focus our attention on what's going on here. So in the calculator, just 5 squared minus 4 times 1 times 2. So I think that's 17. Square root of 17 won't simplify, and so we're finished actually with the answers. The only thing you might do is write them as two separate answers. So that would be -5, don't forget the negative, minus square root of 17, all of that over 2. Sometimes students will just, not extend that fraction bar. And then -5 plus square root of 17, all over 2. Okay, a couple more examples here. If you're comfortable, turn off the video, just work them out on your own. I think the solutions on both of these might come back imaginary, which means you have a negative underneath the square root. I believe they are. And then the simplification piece of it is a little bit different. But try them on your own and then come back and check the answers and see if there's any adjustments you need to make. So the opposite of b would make that a positive 2. But under the radical, I'm going to take -2, or b squared. So I would put -2 in parentheses here. If you don't and you entered it into the calculator, it's going to tell you -4. Looks like that's -64. Well, I know square root of 64 is 8, so that negative underneath there must mean that's an I. So let me clean that up. It's just real slow, and look at the organization. Kind of keep this all lined up here, keep bringing down x equals. So this is going to simplify to 8i. So we have 2 solutions here, but they do need to be simplified. So I'm going to write them out separately. So I've got 2 minus 8i over 2. And because I've got this room over here, I'm going to put x equals 2 plus 8i over 2. Okay, I can simplify if I look at all the terms that are involved in this fraction. All of the terms, 2, -8i, and 2, they all have a common factor of 2. Then I can divide out that one common factor. You can't divide out just by picking and choosing common factors. It has to come out of all of the terms here. So 2 divides into 2 once, 2 divides into 2 once. That needs to be there. And 2 divides in here 4 times. So this solution is actually 1 minus 4i all over 1, but I won't show the 1. Same thing here. I just kind of do a real quick inspection. In all the terms, not just ones I pick and choose, like had that been 7i, I couldn't do what I'm about to do. But I see that I can divide out a 2 again. So I end up with 1 plus 4i. In a future lesson, we're going to call these conjugates because they're the same exact thing, except for one's a subtraction problem, one's an addition problem. Solutions occur in conjugate pairs when they're imaginary like this. Okay. All right, and then 12. Now this is not in general form, so I'm going to have to either subtract a 5 to the other side, or I can take both these terms and move them to the other side. You can probably just be easy to just subtract a 5. So opposite b plus or minus b squared minus 4 times a times c. So you can kind of see I've run out of room here with the square root. So let's go ahead and extend that, extend the fraction bar, and then 2 times -1. Alrighty. -4 times -1 times -5. So all of that equals -4. All right, and we're going to kind of look at this and go, well, yeah, that does simplify. It's an imaginary number again. So -4 plus or minus, that's 2i all over -2. So I'm going to separate them. All right, when I look at all these numbers, I don't want my denominator to be negative. It's just kind of a personal preference. So I'm going to divide out a -2 into all the terms, because all terms can be divided by a -2. So that makes that +1. -2 divided into -4 makes that a +2. And -2 divided into -2 makes that a +1. So cleaning this up, I'm going to have 2 up front plus 1i. I don't need to show the 1, so I'm just going to put plus I all over 1, and I don't need that fraction because it's understood. And same thing here, I'm going to divide out a -2. That makes that +2, but a -2 divided into a +2 is a -1. So x equals 2 minus 1i. We don't need the 1. And then, oh, I don't know why I put a -2 here. That's going to be a 1 here. So that's going to be my second answer. So notice that on these last two examples, my solutions were imaginary, and when you use the quadratic formula like this, you're going to get conjugate pairs. We have the same two terms, but one solution has a addition and one has a subtraction. Something interesting we're going to look at in a later lesson, but worth just kind of talking it out right now. All right, that's it.